Electricity is everywhere in our daily lives. From alarm clocks to wristwatches, radios, and cameras, we rely on electric power to make tasks easier and more efficient. Imagine waking up in the morning, turning on the lights, and using appliances all thanks to electricity. It powers pumps that lift water, lights up homes and streets after sunset, and keeps factories running. Without electricity, our routines would be much more challenging. Have you ever wondered how electricity reaches your devices or what happens when the power supply fails? In such cases, we often turn to battery-powered torches for light. Let's explore how electricity works and why it's so essential. Electric cells are the heart of many portable devices. If you look closely at an electric cell, you'll notice a small metal cap on one side and a metal disc on the other. These are the positive and negative terminals, clearly marked with plus and minus signs. The cell produces electricity from chemicals stored inside. When these chemicals are used up, the cell stops working and needs to be replaced. Electric cells are used in torches, clocks, and countless other gadgets. Understanding the structure of an electric cell helps us appreciate how it powers devices, especially when electricity from the grid isn't available. When the power supply fails, a torch comes to the rescue. The torch gets its electricity from an electric cell. Inside the torch, a bulb lights up when switched on thanks to the cell. The bulb itself has a glass case fixed on a metallic base. If you look inside, you'll see a thin wire called the filament. This filament glows when electricity passes through it. The bulb has two terminals, just like the cell, and both are essential for the bulb to light up. Understanding how a torch works helps us see the importance of electric cells and bulbs in providing light when needed. Filament inside a bulb is a thin wire that emits light when electricity flows through it. This filament is supported by two thicker wires which connect to the bulb's base and tip. The base and tip are the bulb's terminals, and they are designed so they don't touch each other. When the bulb is connected properly to an electric cell, the filament glows, illuminating the space. If the filament breaks, the bulb fuses and stops working. This simple design is found in bulbs used at home and in torches, showing the importance of the filament and terminals in lighting. Make a bulb light up using an electric cell. You need to connect the two terminals of the cell to the two terminals of the bulb with wires. This activity demonstrates how electricity flows through the circuit, making the bulb glow. Using colored wires, you can easily see how connections are made. The wires are attached to the cell and bulb, and when connected correctly, the bulb lights up. This experiment helps us understand the basics of electric circuits and the importance of proper connections for electricity to flow. Connecting wires to the bulb and cell in different ways, you can observe which arrangements make the bulb glow. This experiment shows that only certain connections allow electricity to flow, completing the circuit. If the wires are not connected properly, the bulb won't light up. This teaches us about the importance of a complete path for electricity to flow. Comparing arrangements helps us understand why some circuits work and others don't, reinforcing the concept of a closed circuit. Using a pencil to trace the path of electricity along the wires helps visualize how current flows from the cell to the bulb and back. In arrangements where the pencil can move from one terminal to the other without interruption, the bulb glows. If the path is broken, the bulb does not light up. This hands-on activity makes it clear that a complete circuit is necessary for electricity to flow in power devices. It also highlights the importance of proper wiring and connection. Connecting the wires from the cell to the bulb in 6 different ways, you can observe which setups allow the bulb to glow. This experiment demonstrates the importance of a complete circuit. When the circuit is closed, electricity flows and the bulb lights up. If the circuit is open or improperly connected, the bulb remains dark. This activity reinforces the concept of electric circuits and the need for proper connections to ensure the flow of electricity. Bulb may fuse for several reasons, but one common cause is a break in its filament. When the filament breaks, the path for electricity is interrupted and no current can pass through. As a result, the bulb does not light up. This highlights the importance of the filament in the bulb's operation. Understanding why bulbs fuse helps us troubleshoot lighting issues and appreciate the delicate nature of electric circuits. Electric circuit is a complete path for electricity to flow between the terminals of an electric cell. When the circuit is closed, current passes through the filament of the bulb, making it glow. The direction of current is taken from the positive to the negative terminal. If the circuit is broken, the bulb does not light up. This concept is fundamental to understanding how electrical devices work and why proper connections are essential. You can create a simple torch by connecting a bulb and a cell with wires. Wrap one end of a wire around the base of the bulb and fix the other end to the negative terminal of the cell. Bring the tip of the bulb's base in contact with the positive terminal. The bulb lights up, demonstrating how a basic circuit works. Moving the bulb away from the terminal turns the light off, similar to using a switch. This hands-on activity helps visualize how circuits operate in everyday devices. Switches are devices that either break or complete an electric circuit. You can make a simple switch using drawing pins, a safety pin, wires, and a board. When the safety pin touches both drawing pins, the circuit is complete and the bulb glows. Moving the pin away breaks the circuit and the bulb goes off. This principle is used in all household switches, though their designs are more complex. Understanding switches helps us control electrical devices safely and efficiently. The safety pin covers the gap between drawing pins. The switch is on and the circuit is complete. The bulb glows because current can pass through the safety pin. If the pin is moved away, the circuit is broken and the bulb goes off. This simple mechanism is the basis for all switches used in lighting and appliances. It shows how a switch can control the flow of electricity, making it easy to turn devices on and off. Switches used in homes are based on the same principle as the simple safety pin switch, but their designs are more complex for durability and safety. They allow us to control the flow of electricity to bulbs and other devices. By breaking or completing the circuit, switches make it possible to turn devices on or off with ease. Understanding switch design helps us appreciate the convenience and safety they provide in everyday life. Looking inside a torch reveals how the circuit is completed when the switch is closed. The bulb glows as electricity flows through the circuit. Drawing a red line to indicate the complete circuit helps visualize how the components are connected. This understanding is essential for troubleshooting and designing simple electrical devices. It also shows how switches play a crucial role in controlling the circuit. Materials used in electric circuits can be conductors or insulators. Conductors allow electricity to pass through while insulators do not. Metals like copper and aluminum are conductors and are used for making wires. Rubber, plastic, and air are insulators, used for covering wires and making plugs and switches. Testing different materials with a conduction tester helps identify which are conductors and which are insulators. This knowledge is crucial for designing safe and effective electrical circuits. Using a conduction tester, you can check if a material allows electricity to pass through. By bringing the free ends of wires in contact with different samples, you observe whether the bulb glows. If it does, the material is a conductor. If not, it's an insulator. This experiment helps us understand why certain materials are used in electrical devices and others are not. It also reinforces the importance of safety when handling electricity. Conductors are essential for making electric circuits. Metals like copper and aluminum are commonly used because they allow electricity to flow easily. Insulators like rubber and plastic are used to cover wires and make switches, preventing accidental contact with electricity. Understanding the role of conductors and insulators helps us design safe circuits and use electrical devices responsibly. Insulators do not allow electricity to pass through. They are used to cover wires, make plug tops, switches, and other parts of electrical appliances. This prevents accidental contact with electricity, ensuring safety. Air is also an insulator, as demonstrated in the switch experiment. Understanding the importance of insulators helps us appreciate their role in electrical safety and device design. You can test everyday objects like coins, cork, rubber, glass, keys, pins, plastic scales, wooden blocks, aluminum foil candles, sewing needles, thermocol, paper, and pencil lead to see if they're conductors or insulators. Using a conduction tester, bring the wires in contact with the objects and observe if the bulb glows. Record your observations in a table. This activity helps identify which materials are safe to use in electrical circuits and which are not. When the bulb glows during testing, it means the object is a conductor. Conductors allow electric current to pass through, making them suitable for wiring and circuits. Insulators, on the other hand, do not allow current to pass and the bulb remains dark. This simple test helps us understand the properties of materials and their uses in electrical devices. Your body is a conductor of electricity, so it's important to handle electrical appliances with care. Always use insulated tools and wear rubber gloves when working with electricity. Insulators like rubber and plastic are used to cover wires and handles of tools to prevent accidental shocks. Understanding safety precautions helps protect us from electrical hazards and ensures safe use of devices. Let's recap the main points. An electric cell is a source of electricity with two terminals, positive and negative. An electric bulb has a filament connected to its terminals and it glows when current passes through. In a closed circuit, electricity flows from one terminal of the cell to the other. A switch is used to break or complete the circuit. Materials that allow current to pass are conductors, those that don't are insulators. These concepts form the foundation of understanding electricity and circuits. Sometimes the bulb does not glow in certain circuit arrangements. This happens when the circuit is not complete or when an insulator is used instead of a conductor. For example, if a jute string or thermocol is used, electricity cannot flow and the bulb remains dark. Understanding these scenarios helps troubleshoot circuit problems and reinforces the importance of using proper materials. To make the bulb glow, the free ends of the wires must be joined to complete the circuit. If the circuit is open or interrupted by an insulator, the bulb will not light up. This simple principle is the basis for all electrical devices and highlights the importance of proper connections and materials. Switches are used to control the flow of electricity in a circuit. They make it easy to turn devices on or off by breaking or completing the circuit. Electrical gadgets like lamps, fans, and appliances have switches built into them for convenience and safety. Understanding the purpose of switches helps us use electrical devices efficiently and safely. The bulb glows when using the conduction tester. The object is a conductor. Conductors are used for wiring and circuits because they allow electricity to flow. Insulators are used for safety, covering wires and making handles for tools. Electricians use rubber gloves and tools with insulated handles to prevent shocks. Understanding the difference between conductors and insulators is essential for safe electrical work. Imagine a month without electricity. How would daily life change? You can create a story or play to explore the scenario. Set up games like How Steady Is Your Hand, using electric circuits to test your skills. Learn about inventors like Alessandro Volta and Thomas Edison, who contributed to the development of electric cells and bulbs. These activities make learning about electricity fun and engaging, encouraging creativity and hands-on exploration.